Hello guys, if you like my awesome gaming videos, my programming and web development courses, my editing courses and editing videos, and my tech talks and tech guidance, then you can consider subscribing to my channel and click on this bell icon to stay connected with me all the time. Welcome to my channel. So this is a very important series for you. So in this particular video, I'm going to talk about how you understand the equations of a straight line, parabola. So in this video, I'm going to talk about the straight line equation, which is really important. For that, you need to understand a lot of basic as well, and how the equation comes and what are the important concept regarding it. And not only that, we are going to working with the parabola equation, the y is equals to root over x, y is equals to 1 by x equations, and different kind of equation, why they are like that and why the graph is so important to understand in a root level. Equation of a straight line, we all know that the equation of a straight line is equals to y is equals to mx plus c. Okay, so I think you guys already know what all this meaning is. So in case you don't know, I'm writing this m is the slope. Okay, so this is the slope, and this x is the variable, and this c is the intercept. Now what that means, this x variable is the independent variable and y is the dependent variable. Based on x, we're going to define what would be the output of y. If the x value is 2, then the equation will definitely become m into 2 plus c. So based on that, our equation changes. So we know that our straight line equation is similar to this. Suppose this is 0, 0 point, and we just draw a straight line, okay, which we call y is equals to mx. Now why this is y is equals to mx? Because it is coming from the center. If it is coming from the center, there is no intercept c. C is actually the y-intercept, and I should write it y. Which y point it cuts? Because it is not cutting any y point, it is coming from the 0 to 0. That's why I don't need to write mx plus c. So this is the main thing that you need to understand. Now let me draw one more equation. Suppose this is 1, 2, 3. This is minus 3, minus 2, minus 1. This is 1, 2, 3. So all the thing in the right side, x value is positive. If it is on the left side, the x value is negative. This is the basic thing. The y value, the upper side of the y value is always positive, and the lower side of the y value is always negative. So if I write it like this, it should be minus 1, it is minus 2, it is minus 3. You don't need to be really perfect. It's very easy to understand, and the upper side is always positive. 2, 3. Now if I write one more equation like this, from 2 to like this, okay, then it is intersecting the y-axis in 2 points. So in that case, the equation would be y is equals to m, which is the slope, and the x plus 2, because it cuts the y-axis into 2. These two position, it cuts in 2 of the y-intercept. So this should be positive 2. If it cuts like this, then it would be y is equals to mx minus 2, because it cuts the minus 2, the lower part of the y-axis, which is minus. And you should already know that this part is the third quadrant. This is the first quadrant where all the values of x and y are positive, and in the third quadrant all the values of x and y are negative. See, if we go to the left side, x is negative. If I go to the below side, the bottom side of y, it is also negative. Okay, but if we go to the second quadrant, this one here, all the thing y is positive but x is negative. So you need to know the basic idea of the quadrant. When all the x and y are positive, this is the first quadrant, this is the second quadrant, this is third and fourth. Okay, so this is the thing. In the fourth quadrant, see, x is positive but y is negative. So you need to identify those things. The coordinate geometry is really important to understand the graph. But what is the main thing, that y is equals to mx if it comes from the center point, from the 0 to 0, and if it cuts at the y-intercept, then the value of c is changes to 2, and if it is if it cuts the negative of y portion, then it is mx minus 2. So depending upon the cut of y-axis, is value of the c changes. This is the c that is differentiating. Now also we have one more thing that will differ. See, every one of the straight line has the same kind of slope. The slope is defined like rise over run. So if I write it for you, the slope m refers to rise over run. The rise is y2 minus y1, run is x2 minus x1. How many portion the x increases? The rise is actually the y-axis improvement. From this position to this position, I'm increasing the value of the y from 1 to 2. But if I go to this position to this position, I'm going from x1 to x2. So this is our run, the value of the x-axis, how much it has improved. And if I go to rise, it means that I'm going from y1 to y2. So what is the difference of the vertical axis, which is the y-axis? So our equation is like that. The difference of the vertical axis y2 minus y1 and the difference between the horizontal axis x2 minus x1. So this is actually the slope. It means that how much it is going upward. If it's like this, suppose if I draw one more equation, suppose it's like this, okay, and this is 0 0, and this is suppose 1, this is 2, and this is 1, this is 2, and this is 3. So it cuts at 2, 3, because 2 is the horizontal axis and 3 is the vertical. This is the y and this is the x. 2, 3. And if one more thing here, so one more point, this is x3 quadrant, and so this is x value is 3 and the y value is 1. Okay, so there is a very small changes. So these are the two different kinds of slope. One is going very upward sloping and another one is not that high. It's very small changes. So if it goes very high, the slope will be really higher. And if it is going very slowly, like it is not increasing that much, very slowly it is increasing like this, then the value of the y is very small. As you can see, it's only 1 and here is 3, and that's why the slope would be higher. And if I calculate it, the slope would be different. So slope of m1, suppose this one, and y2 minus y1, so 3 minus 0, and x2 minus x1, which is 2 minus 0, which is 3 by 2. In case of m2, which is this one, m2, and its slope is, this is y, so 1 minus 0 divided by 3 minus 0. So y1, y2 minus y1, x2 minus x1, which is 3 minus 0, which is our x2 minus x1 and y2 minus 1 in the upper side. So what is the thing? 1 by 3. So which one is bigger? Definitely this is bigger. Depending upon the m value, because m is higher here, our slope is very on the upward direction. It is changing very, it is going upward. But for m2 it is not. It is very sorry looking. It is not improving that much. Okay, slight slope. It is not that intense. So for this, you need to understand the slope very well. So based on that, it will just improve. So it can go from here, it can go even like this. Then the slope is very lower, very tiny. And if it goes up to like this, it means that the slope is very high and the value is changing rapidly. Okay, then the m value is much higher compared to any other thing. Then if you put all the value of m, x, then the equation completes. If I put the value here like this one, here suppose our value is this, suppose I put the value of 2, y is equals to m value suppose is 3 by 2, times x value is equals to x, and it is coming from 0 to 0, so there is no c value is 0. So y is equals to 3 by 2 x. So this is our main equation. Okay, if we put the value of m and intercept, which is the y cut, at which position it cuts the y, because it doesn't cut any position in the y. It is not like that. If it is like that, then it cuts the value inside c. Then we should put 3 here. Okay, and if it cuts at 2 position here from 2, then we should write 2 here in that case. So it cuts from 0 to 3.1. So now in that case, it is not cutting any y-axis, it is coming from 0 0. Then you can write it 0 here. So 3 by 2x. So this is the most important thing that many people won't teach you. So this is the thing that hide a lot. So you need to understand the value of slope changes from this curve to this, from higher position to lower position. So the slope changes is very, very important. And to understand the which position they cut the y-axis, y-intercept, which is c, this is also very important. So based on this m and c, and if we now put any x value, you can easily find the y value. Okay, so if I want to find the value of, suppose 1.5 here, you just put 1.5 and you will get your y. Okay, you will get your y like this position. You can calculate it and you can find it, but this is not the important thing. Important thing to understand the concept, why we should use it. Okay, and this technology is used in many cases in machine learning, artificial intelligence, and many data analysis and predictive model analysis in general. This is super important to understand. And the slope can be negative. If I go from here to here, the slope would be negative. If the slope is here, m is equals to positive 3 by 2, here what we have found here 3 by 2, and if I go to the negative side, it will be minus 3 by 2. There is a reason to it. If we calculate it, you will find it. Just make a point here and give it whichever coordinate and try to calculate it. You will get m is equals to minus 3 by 2 because it's in the third quadrant, and third quadrant are always negative. Okay, and it means that if your slope is like that, it means that you are going down, you are downgrading, you are decreasing the slope. It means that you are not improving. Your graph is going down, your progress is going down, your slope is going down. You are not increasing, you are not going to upward trend, you are going to downward trend. That's why it's negative. It is downward trend. Okay, so that's why it is very meaningful to go to the negative of the slope. Then your equation would be like different, and your equation would be minus 3 by 2 x. Then your equation would be minus 3 by 2x plus 0. So then your equation also would be changing. Okay, so if you're going to the downward trend, if it's going to the upward trend, it means that you are improving. The value that you're calculating is improving, and here it means that you are going to the decreasing side, you are downwarding. Okay, so both the cases are possible. So based on those parameters, the equation changes differently. Once the c changes, once the m changes, if it is positive, it is going to positive. If it is downward, it is decreasing, then it would be negative. So based on different kinds of scenario, it is changing. So to understand this, these are the concept are really important. Which position it cuts in the y-intercept, which is c. M is the variable that you want to calculate on. If you put 2 value, what to do with the output in the y, you can calculate any other thing. If you find the m, the slope, and the intercept, you can calculate anything. You can find any equations really easily. Now let's understand the parabola, or you can say the quadratic equation, and it can be like any format. Y is equals to x square format. It can be like x is equals to y square format, and it can be different. You can apply plus, minus, or whatever format. It can be like different kind of thing. If I just draw it, it can be like this format, and it can be like the upward direction as well. So for this, the equation would be y is equals to x square, and for this it would be y is equals to minus x square, because it is downward. Anything below downward is the negative. Okay, so this is really important. Anything the upward is mostly positive in the graph. So if I just draw it in different kind of scenario, there is one more equation. If I just draw it it can be like this. It is following the x-axis, then the equation changes. In this case, when it is going across the y-axis, it is a smiley face, and if it is going to the right side, the equation definitely changes. It would be x is equals to y square. And if it goes like this, also it can be y is equals to x is equals to minus y square. So there can be different kind of combination, but this is not the thing that I want to teach you. This is already in the book, this is already in the other YouTube tutorials and many other things. What I need to understand is how it is building, why it is building like this. So for that, let me just draw one thing, and here I will just point different kind of point here. This is -1, -2, -3. As it is third quadrant, all the thing is negative. So this is 1, 2, 3, 4, all of the thing. Suppose our x value is 1, then y is equals to x square. So 1 square, which is 1. Okay, so x is equals to 2, then y is equals to 2 square. This is quadratic equation, so it will increase like square. Okay, so this would be 4. If x is equals to 3, y is equals to 3 square, which is 9. So it is increasing. If x is equals to 1, y is equals to 1. So x is equals to 1, y is equals to 1. This is this point. And I increase the x value is equals to 2, then the y is equals to 4. X is equals to 2, y is equals to 4. See? And if x is equals to 3, y is equals to 9. So if x is equals to 3, y would be like this here. Okay, so I'm not writing this far. It should be like this kind of equation. It would be like this kind of equation. Y would be like here. Okay, so as you can see, this is the pattern. And for the negative value as well, suppose x is equals to here 1, y is equals to -1 square, which is 1, because anything y square is positive. Okay, so similarly x is equals to 2 minus 2, y is equals to -2 whole square, which is 4. So similarly, if x equals to -1, y is equals to 1. Okay, and if x is equals to -2, y is equals to +4, so it would be here. So our 4 parabola would be like this. So this kind of parabola, although this is not the perfect shape, you can imagine this should be like this. Okay, this is the equation of parabola. So that's why based on this value, if we put all the position, it forms this kind of graph, this kind of shape. So that is why it is parabola, it is quadratic equation. If I increase the x value little bit, the y value just skyrocketed. Like if it's 2, it is y value is 4. If the x value is 3, y value is like out of this page, it is here. So just increase the x value little bit, one by one, the y value will increase like in quadratic equation, like square, it will improve. And for positive segment and on the negative segment as well, if the value is of the x is negative here, all the values are x is negative, still it is going to be y would be positive, because it is square relation. It would always be positive portion, and y is always negative below the x-axis. From this position to this position, y is negative. But if I go to the upper segment, here y is positive. So the equation, as it is quadratic equation, the value would be always positive of the y. See, if I consider this equation, the value of y would be always positive, because this is the x square value. So it is squaring every value, so it is always going to be positive. So you won't see if the value would be like here. You won't see that. It is always positive for this equation. So this is very, very important to understand. And you can also imagine for all different kind of combination. So it is your assignment to find all the combinations of this equation and try to find it why it is like that. Okay, so that's why y value is always positive across this, because it is a square function, and square function always gives an output of positive. Okay, even the x value is negative, it will always output as positive. Now let's understand for the cubic function y is equals to x cube, how it looks like. So you already know how we derive it. Suppose if I take the value of x is equals to 1, then the y is equals to x cube, which is also 1. So let's derive it. For x is equals to 1, for x is equals to 1, y is equals to 1. And for x is equals to 2, y is equals to 2 cube, which is 8. So it is increasing significantly. For the quadratic equation, you see if we just increase the y value just 2 to 3, it increases the y value dramatically because it is squaring every function. But here it is more powerful. It is cubic function, which is more powerful than quadratic function. So that's why if the x value is 2, then y value is 8. So y value is 8, it would be like here. Okay, it's if I just increase it, so it would be like here. But in case of quadratic, it would be like if the x value is 2, y value is 4, it would be here. But in case of the cubic equation, it was more higher. Okay, so similarly for the negative value, if the x is equals to minus 1, now here it would be different. Y is equals to minus 1 cube, which is minus 1. Now see, if the x value is negative 1, then y value is negative 1. So as you can see, if the value of x is negative, y would be negative. So x1, if the x1 is negative, y would be negative because it's cubic function. That's why it is negative. So if we don't understand why it is like that, minus 1 times minus 1, which is plus 1. And if I add one more, times minus 1, which is minus 1. So it would be negative. Then if the x value is equals to minus 2, y value is equals to minus 2 cube, which is minus 8. So if the x value is equals to 2, y value will be minus 8. It would be like here. Okay, then our function would become like this. Okay, and our another function would be like this. So this is the type of function. If I just draw it like that, it would be like this to this type of function. The value, if the x value is increasing slightly, the y value just skyrocketed. See how much it improved. It is much better. It is much improved compared to the y is equals to x squared, because it is improving for each value of x. It is just skyrocketing the y value so highly compared to the quadratic equation. That's why the cubic equation is much powerful. The each value of x, if is increasing the x value a little bit, suppose this is x is equals to 1. If I increase the x value is equals to 2, it is going, y value would be 8 here. Y value would be 8. So it would be 1,8 position. So how much it is improved. And if the yx value is equals to negative 1, y value is also negative 1 here. If I increase the x value negative 2, y value just reaches here, which is negative 8. Okay, so see how much difference it is, so that's why our equation is like that. And you won't find one portion, positive portion is here and negative portion is here, because for every value of x, if it is negative, if the x values is negative, it would going down there. This is the tail of this graph. And for every positive value of x, it would go to the positive side. Okay, it will go to the upward trend. And for every value of negative, it will go to the downward. Okay, you will never see this kind of function that will go here. No, it is not going to happen. Based on this value, the graph would be like this. One position will go to the third quadrant. This is our third quadrant. And one portion, which is the positive portion of x, would go to the first quadrant. So that is the thing that you're going to understand. Why the cubic function graph is like that. Many people don't try to, so that's why you need to understand why the cubic equation or cubic function is like that, and their graph why is like that. Many people just remember it, just memorize it, but this is not the thing. If you just put all those values, the graph would be like this, and this is completely different thing. You don't need to memorize it. It should be inside your memory. Based on this value, the graph is like that. There is nothing to memorize here. So this is the main thing that you need to understand here. Now let's talk about one more very important function why most people really stuck about why it is like that, and they get stumbled and they get really stuck and just don't try to understand why the equation is like that, and they don't even understand the graph, and they just really memorize all of those things, which I really don't like. That's why I'm making this video, to understand why it is like that, why it is functioning, and what is the thing that is going inside, so that you can really understand what is going on. Okay, so the inverse function y is equals to 1 by x. So you just need to understand why it is like that. In physics you need to understand this kind of logic a lot, because the inverse relation, if x is very high, then y is very low. If the value of x is very small, close to very negative infinity, the y would be positive infinity. So this is the thing that is very important. So first we need to identify the x value. Suppose x value is equals to 1. Similarly, we'll understand y is equals to 1 by 1, which is 1. So we're gonna do it. This is for the positive. And then x is equals to 2. Then y is equals to half. Okay, so the 1 by 2. Now we put the value of 2, which is half. See, if I increase the x value, the y value is decreasing. So this is the inverse relation. Okay, so this is the inverse relation. This is really important for this is the really important for you to understand many of the concepts in physics as well. And for integration, differentiation, those understanding the graph, those functions are so important. That's why I'm making this video, because I have a plan to teach you about integration, why it's so important, of applications of it in rocket science, in economics, in just calculating any instantaneous value, dynamic value, and find the area under the curve. All of those things I'm going to talk about everything in the next part as well, in the next video. If the x value is 3 here, y is equals to 1 by 3, which is very small value. Now if I increase the x value is equals to, suppose, and make sure the equation would not be happening. If the x value is 0, then y would be infinitely large. So I'm not doing it. I'm just keeping the value of x is equal to very, very small. So the x value is really small. Then the y value would be 1 by 0.001, which is very high value. Okay, so because the lower part is very small, the upper part is high, it means that the y value would be so much higher. When you are just decreasing the value of x, y is increasing a lot. So this is the inverse relation. So x is equals to 2, y is equals to half. Would be like this. When the x value is equals to 3, y is equals to 1 by 3, which is like this. So it is going very, 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 very small. Why? When you increase the value of x to infinity, y is going very, very smaller. Okay, but in case if I increase decrease the value of x here, and decrease the value of x, y value is skyrocketing. So inverse relation, when the x value is very small, y is very high. So after that it would just decrease like this. If I decrease the value of x here, suppose the value of x is 0.001, then the y value is highest, like this. Here y value is highest. Okay, so and when the x value is 3, like x value is 3, y value is 1 by 3. 1 by 3 is like this here. If I increase x value is equals to 4, then y is very smaller here. So if I increase the x value, y value is getting very smaller. Okay, this is for the positive side, positive infinity. Okay, if the x value is like positive infinity, it is that small, the y would be that much higher. Y would be very high. It would be like positive infinity. It would be that much high if the x value is smaller. If x is very, very smaller, y would be very, very high. Like as you can see, if the x is very small, y is very high. But when x value is very high, y value is like negligible. This is very, very small, very, very small value of y. But here, when the x is very close to 0, y would be like very, very high. Okay, and this also works for the negative value as well. So if I put x is equals to -1, y would be y1 divided by -1, which would be -1. Okay, if x value is -1, y is -1. It would be like here, similar to this. But if I put x value is equals to minus 3, y would be 1 by minus 3. Okay, x value is equals to 3, y value would be minus 1 by 3, which is here. You already understand it, how it should look. It should be like this. When the x value is very high, y value is very small. When the x value is very, very small, y value is really, really, really infinitely large. It is going to the infinitely large. Okay, when the x value is very, very, very small. And it also works for the negative portion as well. And this is the quadrant 3, so you should consider the y at the negative portion and also the positive portion. So that's why the equation and the graph is like this. So you need to consider both of the cases. Based on this value, if we put on this, the graph would be like this. So if you understand the graph, understand the trend, what is happening based on this variable, you would be like crazy. You would be really, really intelligent in the future if you just do future calculations, machine learning, artificial intelligence, understanding physics, understanding Maxwell's equations, Schrodinger's equation, where you need to do a lot of differential calculations based on this graph. You need to find the area of this. A lot of things can happen in the future. You need to understand this equation. So one more thing left, one more equation left, where I'm talking about the square root equation, where many people should know. So these are the more 4 or 5 equations you must have to have an idea if you want to do something big in your future. But so here in the last part of the video, I'm going to talk about the square root function. Y is equals to root over x. You know that in the value of x can't be negative. Inside the root, we can't add a negative value. It is not possible. It is not defined. So I'm not considering the negative side here. The graph would be also, depending on those kind of scenario, the graph would be like this. Graph would be on the positive side, because the value of x inside the root can't be negative, which is you can't calculate it, which is be an imaginary number. I'm not talking about the complex number here. I'm just talking about the real number here, what you can do. So that is the thing that you really need to understand based on this graph if you want to make the graph out of it. Like previously what I had done in the previous examples as well, I'm gonna take the value of x here, like x value is equals to 1. Okay, then the y is equals to root over 1, which is also 1. So this is the thing that I'm gonna take. So if the x value is equals to 2, then y is equals to root over 2, which is 1.41 something. But this is the thing we don't need to consider. If I consider x is equals to 4, then y value is equals to 2, because root over 4 is equals to 2. Similarly, if I take the value of x is equals to 9, then y is equals to root over 9, which is y is equals to 3. So like see, if the x value is 1, y value is 1. Very simple. Then if the x value is 4, if I consider this one, then the y value is 2. If the x value is 4, y value is 2 here. If the x value is 9, suppose 7, 8 and 9. If the x value is 9, y value is 3. So it is increasing slightly increasing. If I consider it, this is the 3. So if I increase the x value too much, well, 1 for 1, y is equals to 1. If the x value is 4, as it is a square root, it is just decreasing the value. So the y value is not increasing that much regarding the x value. If I increase the x value to 4, the y is not very much. It is only 2. From 1 to 2, it is just increased slightly. And if I increase the x value very high, from 4 to 9, I have increased the x value dramatically. It is a huge increase from 4 to 9. But still, our value of y increased from 2 to 3. Only one value increased from 2 to 3 here. If I increase the x value like 4, 9, the y value is increasing very slightly. It is not increasing that much. So it would be like this. It would be like this. It is not gradually increasing. It is gradually increasing, but not too much. If I just draw it more perfectly for you, it is like this. I'm increasing, but not too much. See the difference of this, the difference of this. There is not too much difference. Very slight difference. But the x value is increasing dramatically. Y value is not changing. Y value is not changing that much. It is the y value is increasing very slowly, so it is not that much difference. But in the beginning it is little bit of changing, but after that it is very steady change. It is not that dramatic change that you are seeing here, that what you observe here. So this is how the graph is functioning. Many people try to, why we need to memorize this, that y is equals to root over x function is graph is like that, why it is, and why there is no negative, why I can't just write it like this. Because in other equations we consider the negative portion. For the cubic equation, if you remember, for 1 by x equation also it would be like this and this. But why we are not considering the x value is negative? Because it is inside the root, square root. We can't take negative value of x so that we can consider this portion. Okay, we can't consider this portion, we can't do this. So that's why our equation is like that. The equation will be y is equals to root over x. So this is our equation. So if we understand every single 5 or 4 equations here, you need to understand every single of our equation that I have taught you here, and try to grab this knowledge and why it is like that. Just try to understand it. If you, for example, you can try it for the ln x, for the e to the power x, all of those stuffs. So these 4 things are the basic. I don't want to drag it too much. For your example, you can also work with this e to the power xy equation is like different way, and you can also think about this ln x equation. Okay, so for your assignment you need to figure it out, why e to the power x equation is like that, why ln x equation is like different. It is different equation, and e to the power x also different equation, and also the graph would be different. You just need to find out why they are like that. I also just showed you how you just imagine it. Okay, how you imagine it, that's how we should learn it. So that's why I'm making this video, so that you can identify how we researcher identify different kind of graph based on the value of different kinds of input, how the output would be like. Okay, so this is the real thing of the mathematics. So till then, take care, bye bye. I'll see you in the next video with more awesome and beautiful content, where I'll talk about integration and its use cases in general, where you will love it a lot, I think. So till then, take care, subscribe, and much as much possible, and like and share as much as possible, so that I can get more motivated to give you much better content like this in the near future.